Okay, so let's talk a little bit more about some of those problem-solving heuristics. Remember, a heuristic is a quick rule of thumb that we engage in automatically to solve problems. So the three heuristics on this slide are the anchoring and adjustment heuristic, the working backwards heuristics, and the means-end analysis. So anchoring and adjustment is simply when you get locked onto a particular number or a value initially, and it changes the way you interpret the problem. So for example, if I was to have you estimate quickly what the product of 1 times 2 times 3 times 4 times 5 times 6 was, you would all come up with some estimation. If I had half of you solve the problem like that, and then half of you, I said, I need you to estimate what 6 times 5 times 4 times 3 times 2 times 1 is. Of course, you don't know about the other question. You only know about the one that you've been asked. The people who are asked the question with the higher number first are going to estimate that the product will be bigger, so that that math will be larger, a larger estimate than those who are asked 1 times 2 times 3, etc. Obviously, with multiplication, it's going to be the same either direction that you do it. But because you anchored on that initial number, you don't adjust properly after you have that anchor. So this is also important for advertising. People will anchor to an initial value if they see it first. And then they adjust their anchor up and down, but usually people don't adjust the anchor up or down enough to be accurate. So it's always better if you've ever seen a sale price tag, the number that it was originally is usually quite large, highlighted big in color, and then you see the sale price a little bit further down. So they want you, as a salesperson, they want you to adjust or to anchor to that higher number and expect that that is the price that you should be used to, that you should be expecting. And then they'll let you adjust down for sale, but you want to see that first anchor, and that's what's going to make you feel like you're getting a good deal. The working backwards heuristic is quite simple. It's exactly what it sounds like. You determine what the goal state is. So where do you want to go? And then you work backwards to where you are now. So let's say, I want to graduate college. Okay? That's my goal state. And then I figure out the path between where I am now and where I want to be, and that's how I figure out what to do next or how to solve the problem. The means-end analysis is a little bit similar. Its means-end analysis is used in artificial intelligence. It's a kind of cyclical process, so you're going through this cycle of reducing the difference between the current state and the goal state. So how you do that is, well, you have to know where the goal state is, you have to know what you want, and basically you're taking a step in one direction of this problem, and you're establishing or evaluating whether or not you're moving closer to the goal or further away. It's a little less organized than the working backwards heuristic, but it's a similar process by which you're taking a step and seeing if that step takes you anywhere nearer or further away from your goal state. Okay. So I told you there's a lot of problems with problem solving. So if you want to improve your problem solving, the best ways to do that are increase your knowledge. Okay, always learning more, always remembering more information. That's going to help you problem solve. Automate certain components. So if you can make something automatic, that's going to make problem solving easier. Follow a plan. Work backwards. So, look for where you want to go and figure out how to get there. So that's kind of a big picture thought. Practice, and then also be mentally flexible. So being able to reconceptualize the problem, search for a relationship among the problems, searching for contradictions within the problem. All these things are ways to increase problem solving. So daily we make lots of judgments and decisions, and usually, like I said, we use those heuristics, we use shortcuts to make those judgments and decisions. When we are judging the likelihood of something, Remember, likelihood can range from, I think it's 0% likely that this will happen, or 100% likely that this will happen. And we judge probabilities, unfortunately, using heuristics, which are not always super helpful, right? So you can fall into traps with estimating probability. The two main heuristics that we use for judging probability are the representativeness heuristic and the availability heuristic. Okay, and you might have read or watched a video about those things already on the crash course. That's fine, but I just want to reiterate that with them quickly and provide some examples. So this is a clicker question that I'd have you do. I'll give you, 30 seconds to read it. Okay, so what is Sarah more likely to be? Probably not more than one teacher, but a school teacher or a holistic healer. Usually in class, about 60% or maybe 70% of people will choose B, will choose the holistic healer. That is actually incorrect. She is much more likely to be a school teacher. You're basing that estimate based on you're using the representative heuristic to guess that Sarah was a holistic healer rather than a school teacher. And the reason that this is incorrect is because there are so many more school teachers. The base rate is so much higher for school teachers than it is for holistic healers in the United States. So the likelihood of Sarah being a school teacher is much higher, even though she likes doing some of those new agey type things. Okay, basically we judge membership in a category based on the resemblance of that category. So even though we blatantly disregard base rates in the population. So the statistics of how many, the probability, the likelihood of being one thing or the other, being one in one group or another, we disregard that. We really just look at how well the match is between the characteristics of that individual and what we think of in that group. And so that's the representativeness heuristic. Along with the representativeness heuristic, there's a couple of other fallacies that happen that kind of can trip us up mentally. So here's another clear question. Most people will, of course, choose B, an English professor who likes hockey. But, as I said before, the correct answer is A. The representative heuristic says, okay, person who likes to write, read, and interpret poetry is probably an English professor, but there are many more hockey fans than English professors who like hockey. Okay, so there's more hockey fans who like poetry than English professors who like hockey. There are very few English professors in the United States compared to how many hockey fans there are. Another thing about this specific example is that it's an example of the conjunction fallacy. Okay, and the conjunction fallacy states that it's the likelihood of the overlap of two uncertain events cannot be greater than the likelihood of either of those two events, because the overlap is only part of each event. So you can see this Venn diagram we have. If this is hockey fans and this is English professors, the overlap cannot be more than the original category itself. So there's way more hockey fans that exist than English professors who are also hockey fans. Okay, so just based on pure estimates of statistics, we know that this is going to be a better bet than betting on this smaller category. Okay, but we don't do that automatically. We automatically use the representativeness heuristic. So that's the conjunction fallacy. And then it's also important to note that, hold on one second, we have gambler's fallacy can also happen Okay, so the gambler's fallacy is an erroneous belief that the chance of something occurring increases over time if it hasn't occurred in a while. So an example of gambler's fallacy is you're flipping a coin and you're writing down whether you get heads or tails. Well, if you've gotten heads 3 times in a row, you will probably estimate that tails is coming next. In fact, you'll overestimate the likelihood or the probability that the next flip of the coin will be tails. Now, we know mathematically that every single time you flip a coin, unless it's a, weighted coin or something crazy like that, every time you flip a coin, there's a 50-50 chance of it being one or the other. The probability does not change based on what came before it or what comes after it. We know the probability is consistent. It stays the same. So gambler's fallacy is just that adjustment, that expectation of getting the opposite or getting something that hasn't happened and overestimating the probability of that mentally. Now, these processes happen automatically. You're not thinking, oh, it's going to have to be tails, or maybe you are, but we tend to automatically go through that process. Okay? Oops. What's next? So, this is our next clicker question. Are there more words that begin with the letter R or that have R in the third position of the word? Think about it for a second. I have no idea what you guys would respond, but the correct answer is B. There are many more words that have R in the third position than begin with the letter R. And we know that usually most people will respond with A, begin with the letter R. The reason that we do this is because of the availability heuristic. I know you guys have heard about this already. The availability heuristic is simply that accessibility in memory leads to greater estimates of probability. Simply that if you can remember something happening, you think that that's likely to occur in the future, okay? So we estimate it happening more frequently. For example, things like shark attacks, things like terrorist attacks. Remember, after 9/11, sort of somewhat similar to like what's happening right now, airplanes, no one flew in airplanes, everyone drove instead. And driving actually is a lot more inherently dangerous than flying in an airplane, COVID-19 notwithstanding. So the summer after September 11th, 2001, everyone drove, well, not everyone, most people drove on vacation instead of taking airplanes. And it's estimated that approximately 100,000 Americans died in motor vehicle accidents above what was normal because they were driving instead of flying. In fact, flying is quite safe, except for maybe when there's a global pandemic. Okay, but because there were very, accessible memories of plane crashes, you estimate that those are more likely to occur. Okay. Same with shark attacks. Very, very rare statistically, very unlikely, but because they are highly publicized when they happen, they're very emotional, that is something that after one occurs, you estimate that they happen much more frequently. Okay. This can result in dread risk. Okay, so being afraid of things that are, not very likely. There's a much greater fear of shark attacks, even though you're much more likely to die of diabetes. Okay. And next, we're going to talk about probability and decision making in the next video.